Well, after taking a very brief look over the steps that we pass when pit optimization and strategic mine planning, as we saw some of the inputs, the settings, adjustments, as well as outputs. Now we can take a look on the next step, that is tactical mine planning. Tactical mine planning is one of the 3 or 4 main steps of mine scheduling and mine planning cycle that is in many projects neglected. Here I'm showing you an example that is based on the project I showed you for strategic planning. After I created my pushbacks, and I've decided about what is possible about the mining rates and ore throughput to the process plant, as well as anticipated fluctuations in ore grade or qualities, as well as the costs, whether operational and capital costs. I can validate these results by tactical planning, and then add more details to these outcomes, and then pass it to operational planning. Tactical planning can cover short, mid-term, and long-term scopes of time over the life of mine, and depending on the time scope, tactical planning can be very resilient about what are the input parameters, what are the limitations, and what we are going to take out of this step of planning. Well, I have defined these 3 stages, that is the initial pit, pushback 1 and pushback 2. All of them have their definition about the location, as well as the geological model that is supporting our planning. Here the material classes are defined based on the qualities and rock type, the geological data that has been supported to us by the resource geologist. Here I have only 4 simple material classes, including waste, magnetic ore, and hematite ore, and ore that is composed that comprises both hematite and magnetite. And the only quality is Fe in percentage, in average percentage. Again, like what we did for strategic planning, one of the main input data is the resource block model or the grade control block model. When we use tactical planning for especially short term scheduling, it's better to use grade control block model rather than the resource block model or reserve block model. The grade control block model has more detailed and more accurate data regarding the reserve or resource block model, because the data are been gathered and estimated using more boreholes or more drill hole samples. Next, such as every other planning packages or planning approaches, we must define our resources. That my resources here are divided into two general fleets by the name of the company, and the resource capacities are defined here. One of them is based on the volume that per day this fleet of excavators can dig, and the other one is based on mass capacity per day. And here, like what you see in Whittle, that we here changed our mining rate. In MineSched, I've did many variations in the mining capacity based on what I have concluded from many runs, and you see here the final project, the final scenario, I better say, in terms of MineSched, that needs to do these adjustments only for production rates to get to a viable and valid plan or a schedule. Maybe you may need to define some parameters. These parameters are mostly acting as limitations to the algorithm that this package is working based on, such as this parameter that is saying that two adjacent benches must have 50 meters lag between them when they are advancing, and the two benches cannot cannot advance without this 50-meter lag between them. You may define calendar like here, and although the targets, whether they are quality targets, I mean for example, the head grade of FE that you need these planning to adjust based on the adjustments, the settings of your processing plan, or material ratio targets. The most commonly used one is stripping ratio, waste to ore ratio, and many other parameters, limitations, and definitions. And then by running this whole set of data, this scenario, it will generate you many charts and diagrams, as well as graphical results and animation to see how this scenario is working, how the benches are moving, and validate each of these results. I'm clicking each period. Periods here are like any other software packages. Time is an implicit embody. Here the periods are defined based on each months. I have one month is during 30 days, the next month is 29 days, and then 6 months is each of them 31 days. You see that here about 2 years are defined as the periods, and these are our periods here. You see how the faces are advancing, and here by using the designed pit geometry, you can also graphically validate whether accessing these blocks for mining is possible through this ramping system or not. Also, scheduling and planning softwares can deal with haulage. Let's take a look back to strategic planning. In strategic planning, haulage is mostly defined in terms of costs. Every other aspects of mining also can be converted to cost terms and defined in the scenario definitions, whether mining cost, and use formulas. For example, for haulage or mine dewatering, we can say that by increasing the depth of the pit every benches, how much the haulage or dewatering cost is predicted to increase, and in form of a formula we put it here. You see block mining cost adjustment factors to consider only the cost, because in a strategic level we are mostly dealing with the cost, and we are going to make strategic decisions, not the details such as the type of the truck and the site that we are going to enter a new bench that is called drop cut or a ramp cut location. But in tactical planning, we can deal with haulage in more details. For example, in this scenario, each color is one period, and each period is 1 month. Let me check. Yes, each period is 1 month, 18 periods, each of them 1 month, and the first period is 10 days. When I'm showing the progress of this scenario, you see that the angle of the working phase is changing in direction in azimuth, and the point that each bench is going to be open varies depending on the ramping system. Is it clear? For example, here you see that ramping system is going to come down to this bench here. So this bench, when it starts mining, is supposed to start from this location here. See, the drop cut is opening the new bench here. So only in tactical mine planning we can decide about the direction of mining, the mining methods, and next the haulage limitations or considerations and more calculations. You see, the direction of opening each bench varies depending on this spiral ramping system. This pit design only supports one ramping system that causes some concerns and risks to mine operations, in terms that when there is a difficulty or there's a problem arising in this ramping system, we have no other choice for pit exit, and the operation may be halted for several hours or several days. Also, the options to define a blasting block, a dig block, is limited, because we cannot start new benches or advance the previously opened benches from more than one location, and each bench opens only from one location, that is the bench entrance or ramp entrance to that bench level. Any question up to now?
That's all fine.
Well, next let's take a look on Haulage. I unfortunately didn't find my previous scenarios that I have dealt in depth with Haulage, but I can show you very briefly through the tools that in this package. I mean, MineSched has been considered for Haulage. You can define here roads, routes, haul points, exit, and entrance points for your haulage systems to the waste dump or to other destinations such as stockpiles or the crusher site, I mean the processing plant, and define the trucks, mechanical, or I better say performance definitions such as rim pull and retards, specifications, the availability, usability, and efficiency rates, and much more details, and define different fleets, different types of trucks to different routes. And by running this schedule, you can also ask for haulage here in charts and reports. Here publishing results, standard results, you can ask it to export the haulage details in a spreadsheet such as CSV or Excel files, as well as haulage results can be graphically validated here, but I have not defined, so you see nothing about haulage in this window, in this conveys. To check the speeds, the rolling resistance, the sequences, and come to a conclusion. I think I have here one example about what can be one of the outputs when we are dealing about the haulage in our tactical planning. One of the commonly used KPIs in mine planning is TKM, that is the tonnage hauled per kilometer. Tonnage is multiplied by the distance, and you see that over these 25 months we have some fluctuations because the rock type is changing, and for example here alluvium density is very less than the waste rock, whether fresh or oxide rocks. And also based on the destination, that is especially the waste dump, and over the periods, the location that we are tipping out the waste at the waste dump is fluctuating in distance related to the pit exit. We have this variation in TKM, and this TKM can be easily converted to the number of trucks. MineSched gives it itself, no more calculations in Excel needed. That how many trucks I need over this monthly schedule to verify whether it complies with my availability of machinery resources or not. Also, another important result from Mine planning, mine tactical
Sorry,
planning.
just a quick one.
Go on.
Speaking of fleet management and like haulage optimization, does MineSched have all of the like capacities of these specific softwares such as WholeSim and Tallpack, or for a specific and in detail evaluation, we'll need some other packages as well?
Well, you are asking about Haulage simulations. The simulator, and I better say simulating software packages such as HaulSim are based on discrete event algorithms, and their task is to simulate what is going to happen during each cycle of loading and haulage, as well as considering other events such as the pit block because of blasting, or the queuing events because of a motor grader that is passing through the main ramp system and causes um, decrease in the traveling speed of trucks, and so on. These are simulators or simulating software that they are used to validate our assumptions about the production rate of each fleet or each machinery that we are using in scheduling or planning. For example, one should ask, how did I get to this number, 5,000 tons per day, that is possible to be excavated by my fleet of shovels? How did I get to this figure? It must be based on calculations, and especially simulations can help us here. As you see in resources here, we have not defined the haulage fleet capacity. It is assumed that the haulage capacity is combined and defined in terms of the loading fleet capacity, and that simulators are one of the best tools to estimate and evaluate this capacity. Is it clear?
Yes, thank you.
From the results, I can also mention about to some extent similar results between tactical and strategical planning, such as the fluctuations in the grade of Zn element in our oxide and sulfide, or in this case that we see that it is being increased over time, and this scenario is mostly to guide pre-stripping stages, as you see that in many earlier months no ore is produced, and the aim of this scenario was to reach to sulfide ore, not the oxide, and oxide is being piled as a waste in the first 3 or 4 years of this project. Also, stockpile balance is one of the main important results that we can get from tactical planning, also in strategic planning, and in operational scheduling or planning. Stockpile balance charts and diagrams are one of the most required outcomes to check what is the opening figures, what is the end of the month figure if our periods are months in our scheduling or planning, and the qualities that we have at the beginning of the month, the beginning of the period, and end of the period. This is called stockpile balances. Well, any questions? I think that I have overviewed again here, the same as what we talked about uh, strategic planning in our previous session. Here we talked about what is the role of tactical planning and the inputs, limitation, parameters, and outputs. To put in a nutshell, I am again saying that tactical planning, by my idea, has two general roles in mining industry. The first is to validate the results from strategic planning, and the next is to add level of details to the outputs from strategic planning so it can be passed to the more detailed and the real operational and executable schedule or plan, that is operational planning. Any question?
Yep, all good, thank you.
All right, so let's stop this session, and next we can talk about operational planning and scheduling. Bye for now.